Hello students, I'm coming to you with the next video lecture on Chapter 1, Part 2, and this is the second video in this series. So in the last lecture video, we covered the following concepts: types of analyses and types of variables. In this video lecture, we will cover levels of measurement, as well as the difference between descriptive and inferential statistics. At the end of this video, I will invite you to check for your understanding of these concepts. In terms of learning objectives, by the end of this video, you should be able to understand and explain the difference between the different levels of measurement. You should also be able to understand and explain the difference between descriptive and inferential statistics. So let's begin by discussing levels of measurement. All variables have their own level of measurement, and there are four primary ways of measuring variables, which include nominal, ordinal, interval, and ratio. The acronym for this is NOIR. So let's begin by discussing nominal level variables. One of the ways to remember this concept is that nom is French for the word name, and nominal level variables typically include names of things. Nominal level variables provide a way of measuring categorical variables. Within this level of measurement, data are classified into several mutually exclusive and mutually exhaustive categories or attributes. However, the difference between these categories is unmeasurable or mathematically meaningless. In other words, you can't say that male is less than female. So here's an example for the variable party affiliation. There are several attributes that are associated with this variable, which include Republican, Independent, and Democrat. And as you can see, these attributes include names of things. For the purposes of analysis, we can attach values to each of these attributes, where one can be used to represent the category Republican, two can be used to represent the category Independent, and three can be used to represent the category Democrat. However, each of these categories do not have a mathematical meaning associated with them. Here's a code book from a real data set. And within this code book, I'd like to point out to you each of the nominal level variables, which include gender, race, marital status, and considered sick. If we look here to the right-hand corner of this code book, we see that gender is captured by two categories, male and female. And we see that race is captured by two categories, not white and white. Marital status is captured by three categories, widowed, married, and divorced or separated. And considered sick is captured by two categories, no and yes. But as we can see, each of these categories include the names of things, which make them nominal level variables. Now you might be wondering what is meant by the terms mutually exclusive and mutually exhaustive. So here's where I will explain these concepts. So the term mutually exclusive means that the categories do not overlap with one another. And the term mutually exhaustive means that every case can be classified into one category. And the way in which we often do this in surveys is by including an other category. So as we can see here, the question asks, which of the following best describes your current relationship status? And indeed, this variable is mutually exclusive, because each of these categories are categories unto themselves. So the category of married does not overlap with the category of widowed, and the category of widowed does not overlap with the category of divorced, and so on and so forth. So this variable is mutually exclusive, but it is not mutually exhaustive, simply because there is no other category. So if respondents were to look at this item and possibly not find their circumstance or situation listed, there would be no way to capture this unless an other category was included. So this is not what we want. So this variable here is what would be considered mutually exclusive and mutually exhaustive, because it includes various different ethnicities from which a respondent can choose, but it also includes an other category. And so this way, this is what makes the variable mutually exhaustive, because if the respondent does not find their ethnicity listed, they can simply choose the option other. Now we can further improve on this question by also including the words, please specify. And by including the words, please specify, we provide the opportunity for the respondent to tell us what their ethnicity is, so that we're able to capture that within our results. So this is what is meant by the terms mutually exclusive and mutually exhaustive. So now let's look at ordinal level variables. One way in which to remember this is that the letters ORD are at the beginning of the word order. Ordinal level variables also provide a way of measuring categorical variables. And at this level, data are classified into mutually exclusive and mutually exhaustive categories. And these categories also have a fixed order. At this level, we can speak of one category ranking higher or lower than another category. However, these categories are not equally spaced apart. In other words, the difference between categories is unmeasurable or mathematically meaningless. So here's an example of what an ordinal level variable can look like. If we were looking at t-shirt size, the sizes of the shirts have a fixed order that ranges from small to medium to large to extra large. Or if we were looking at places in a race, these places have a fixed order ranging from first place to second place to third place. Now here's an example in an actual data set. The only ordinal level variable in our data set is level of education. And although it may appear that this variable is measured at the nominal level, it actually is not. It is measured at the ordinal level. Because if we look at the categories here to the right, we see that these categories, although they are mutually exclusive, they also have an order to them, with the lowest level of education being less than high school, and the highest level of education being some business or college. So this particular variable is measured at the ordinal level. Now let's look at interval level of measurement. So one way in which to remember this is that interval means gap or distance. At the interval level of measurement, data are classified as mutually exclusive and exhaustive, rank ordered, and there are equal distances between intervals. So take note of the fact that we're continuing to add on these features of the variable as we go, because we know that nominal level variables are mutually exclusive and exhaustive, ordinal level variables are rank ordered, and now we're adding on an additional feature is that interval level variables have all of the characteristics of nominal and ordinal variables, except now we're adding on an additional characteristic, which is that it also has equal distances between intervals. At the interval level of measurement, responses are expressed in continuous numbers rather than categories. Responses at this level also have arithmetic and mathematical meaning. However, there is no 0 point. So a couple of examples of this would be IQ score and final exam score. So we know that one's IQ cannot be 0. Everyone has some level of IQ. Okay, so there's no true 0 point associated with IQ scores. And also final exam scores. Typically, hypothetically, for all intents and purposes, no one ever really makes a 0 necessarily on a final exam. Usually if you show up, you get some points. Okay, so let's just say hypothetically, if you show up, you get some points. So final exam score could potentially be measured at the interval level of measurement as well. So here are some examples from our data set. So you see that these are continuous numbers here, and each of these variables within our data set are measured at the interval level. And these variables are considered to be interval level because there are no categories associated with them. So these are all scales, okay? And I'll explain what a scale is later on in the semester. But these are all scales, and these scales each have a different range associated with them. And as you can see, none of the scales have a 0 point. They all start off with some number. So whether it's 5 to 32, 10 to 32, 7 to 26, 13 to 32, and so on and so forth. So each of these scales represent continuous data. So we're at the interval level of measurement. So we know now that we're dealing with continuous data. So each of these scales represent continuous data. However, there's no true 0 point. Okay, so just keep that in mind. So each of these variables here all represent the interval level variables in our data set. Now let's talk about ratio level variables. So one way in which to remember ratio level variables is that the O in ratio equals 0. Okay, so we know that that's not necessarily true, but it's just one way to remember this, okay, is that the O in ratio equals 0. At the ratio level of measurement, data are classified as mutually exclusive and exhaustive, rank ordered, there are equal distances between intervals, and there is an absolute 0. So ratio level variables are actually the highest level of variable, and they have all of the characteristics of each of the other levels of measurement in addition to having an absolute 0. At the ratio level, responses are expressed in continuous numbers rather than categories. Responses have arithmetic and mathematical meaning, and responses have an absolute 0. So here are some examples of questions that we could ask on a survey that would produce ratio level data. So for example, what was your total family income last year? Well, one's income could actually be 0. How many cigarettes do you smoke a day? The answer to this question could hypothetically be 0. How many children do you have? Again, the answer could hypothetically be 0. So the answers to each of these questions could range from 0 to infinity, okay? So these are some examples of the ways in which we would go about asking questions on a survey in order to produce continuous ratio level data. Now here's an example from our survey. This is from our code book. This is the only variable within our code book that is measured at the ratio level. So it is indeed continuous data because it has a range, right? So from 0 to 47. Notice that there is a true 0 point on this scale. Okay, so this is the only ratio level variable in our data set. So this is just somewhat of a summary, keeping in mind that the levels of measurement build upon one another. Okay, so nominal level data is our lowest level of measurement. And then from there, we increase to ordinal, interval, and ratio is our highest possible level of measurement. And here's yet another summary. Okay, so as we can see, we're continuing to build where nominal level variables are mutually exclusive and exhaustive. Ordinal level variables are mutually exclusive and exhaustive and have rank order. Interval level variables are mutually exclusive and exhaustive, have rank order and equal distance. And finally, ratio level variables are mutually exclusive and exhaustive, have rank order, have equal distance, and also have a true or absolute 0. Also, another thing to point out here is that nominal and ordinal level variables are usually categorical in nature, and interval and ratio level variables are usually continuous in nature. And here are just a few examples of each of these kinds of variables. Now, why is it important to understand levels of measurement? This is something that we will get to when we get into the unit of our course that's related to inferential statistics. However, I want to kind of foreshadow that and help you to understand why levels of measurement is one of the most fundamental concepts that we will talk about in this course. And the reason for that is because knowing the level of measurement of each of the variables that you intend to include in your analysis helps you to decide which statistical test is most appropriate for analyzing your data. It also helps to decide how to interpret your data from that particular variable. And you must consider level of measurement before you collect your data and not after. So these are each of the tests that we will cover in this course, okay? And as you can see here, these are the requirements for each of the independent and dependent variables that you will include in each of these different statistical tests. And so, for example, here for Pearson correlation, the rule is that the independent variable must be measured at the interval or ratio level, and the dependent variable must also be measured at the interval or ratio level. And as you go through each of the tests, you'll see that each one of them has different rules associated with them as it relates to level of measurement. So this is the reason why understanding level of measurement is so fundamental to data analysis and statistics. Now let's talk about the difference between descriptive and inferential statistics. Descriptive statistics analyzes, descriptive data analyses summarize the actual measurements of the variables within our data set. This generally consists of assembling graphs, tables, and descriptive summaries of variables. The purpose of descriptive statistics is really about data reduction. It allows us to reduce large amounts of data into simple and more digestible and understandable formats without necessarily distorting or losing the overall meaning of our data. So descriptive statistics is usually where we begin in any research study. We always want to begin by first describing our population and describing our data. So this is usually the place in which researchers begin the data analysis process. So here again is our code book, and these are all of the variables that are included in our data set. So here are some descriptives that I have run on some of the variables within this data set. So for example, I've looked at what is the average age within the data set. Okay, so what's the mean age? What's the median? What's the mode? And I've done the same thing for the variable physical health, education, as well as race. Okay, so it's always helpful to begin by first describing and summarizing your data in the form of tables and charts and in various different ways in which we can go about simplifying our data in a way that it gives us a really good look at our data. It's very difficult when we look at our data set to see the sea of numbers within the data set, but it makes it very easy to understand our data and exactly what's in our data set if we can run some descriptive statistics on those data to help us summarize and visualize that data. Now, inferential statistics, on the other hand, refers to a group of statistical tests that are used for testing hypotheses about the relationships between variables. Okay, so this is where in our inferential unit, we will begin to talk about these various statistical tests. And they include things like independent t-test, Pearson correlation, analysis of variance. So these are all of the various different tests that a researcher can draw upon in order to test hypotheses about the relationships between variables. These tests help us to make inferences about a population based on data drawn from a sample of the population. And we will get to this later on in the semester, but very rarely in social work research, do we ever study an entire population? It is never feasible, or it's typically never feasible to do this. So we always study samples of a population. And so these inferential statistical tests that we draw upon helps us to make inferences or draw conclusions about a population based on a sample. And we will talk a whole lot about inferential statistics and what it means to make inferences and what the difference is between a sample and a population. We will talk all about that during our inferential statistics unit, okay? But I just want to kind of give you just a little bit of flavor of what we will cover later on in this semester as it relates to inferential statistics. And it's still helpful for you to kind of understand and know what this term means as we continue to journey forward in this semester. So here's an example of a test that I ran using the data set that we have been discussing throughout the course of this video. And so here is where I examine the relationship of the correlation between emotional balance, one's emotional balance, and one's physical health. Okay, and so I used the specific statistical test that I used, or the specific inferential test that I used was Pearson correlation. Okay, so both of these variables are measured at the interval or ratio level. So both of them. Okay, so emotional balance and physical health. And so essentially what I found here, and this is the sort of metric that we use to go about determining how strong this relationship is, whether it's a very strong relationship, whether it's a moderate relationship or a very weak relationship. So we'll talk all about this when we get to Pearson correlation. But for now, I just want you to understand that this is an inferential statistical test. And what inferential tests, again, allow us to do is to look at the relationships between variables. So here is essentially what this table is suggesting is that there is indeed a relationship between emotional balance and physical health, except this relationship is a bit on the weak side. So it is a positive relationship because there is no negative sign here. Okay, so if there was a negative sign here, it would be a negative relationship. But because there's no negative sign, this is a positive relationship. So in other words, what this is saying to me is that as one's emotional balance increases, one's physical health also increases. So that makes a lot of sense, right? So the more emotionally balanced one is, the better physical health they have, okay? So that's essentially what this test is telling me here. But if I want to understand how strong this relationship is, then I need to look here, okay? So I'm going to look on the positive side because this is a positive relationship. So I see here that it's kind of a weak relationship here because this number here is 0.34. Okay, so I'm going to match this number up here with what I see here. So 0.34 is somewhere around here. So it's telling me essentially that although there is indeed a correlation, in fact, a positive correlation between emotional balance and physical health, this correlation is a weak correlation. Okay, so this is essentially what inferential statistics allows us to do. And all of the tests that we will look at will tell us different things. It'll produce different results. So each of the tests are different, okay? And so we'll talk about all of them in terms of what the purpose of the test is and what they tell us and what they're used for. We'll get into all of that good stuff later on in the semester. But I just wanted to show you one example of an inferential statistical test and what role these kinds of tests can play in statistics. So just in summary, we now know that descriptive statistics is all about collecting, organizing, summarizing, and presenting data. And in addition, inferential statistics is all about making inferences, hypothesis testing, and determining relationships between variables so that we might make predictions about those variables. And so again, this is not anything that you need to understand in great detail at this point in the semester. This is just an introduction to the difference between descriptive and inferential statistics as we move forward and toward these topics that we'll get to later on in the semester. So I want to end this video by kind of connecting some dots, because we've talked about a number of different concepts. And so as we get to the end of this unit, I want to just talk a little bit about what I call the anatomy of analysis. And so here are some of the key concepts that we've covered over the last few videos. And they include independent and dependent variables, attributes of a variable, continuous and categorical variables. We've also talked about dichotomous variables, which include binary and dummy variables. We've talked about the difference between univariate, bivariate, and multivariate analyses. And finally, in this video, we've talked about the difference between descriptive and inferential statistics. So here's an example of the relationship that we could potentially look at between gender and depression. And so in this particular example, gender is the independent variable in this study. If we were to be hypothetically doing a study that examined the relationship between gender and depression, gender would be the independent variable. The attributes of gender would be male and female. This would be considered a dichotomous categorical variable, and this variable is measured at the nominal level. Now, if we look here to the right, depression in this study would be the dependent variable, and this variable is continuous and measured at the ratio level. And the reason for this is that we see the score ranges from 0 to 60. So hypothetically, that would mean that this will be a ratio level variable because it has a true 0 point. So this variable depression is continuous and measured at the ratio level. This will be also considered a bivariate analysis because we have two variables in the study, gender and depression. If we wanted to examine this actual relationship using an inferential statistical test, we could do that. So we would examine the relationship between these two variables using inferential statistics. And the specific test that we would use would be an independent t-test. And we have not gotten to that yet, but we will. Now in this scenario, gender and education are the independent variables. The attributes of gender are male and female, and the attributes of education are less than high school, and some college. Gender is dichotomous, categorical variable. Education is a categorical variable, however, it is not dichotomous because it has 3 categories. Gender is measured at the nominal level, and education is measured at the ordinal level, keeping in mind that education is an ordinal level variable because it has a fixed order associated with it. Now here on the right-hand side, depression is the dependent variable. It is a continuous variable, again measured at the ratio level because the score hypothetically ranges from 0 to 60. So that makes it a continuous variable that is measured at the ratio level. In this case, if we wanted to examine this relationship between these 3 variables, gender, education, and depression, we would utilize some type of multivariate analysis because there are 3 variables in the analysis and not 2. We would also use inferential statistics to test this relationship. And I won't get into which test that we will utilize in this case simply because this course only covers up to bivariate analyses. So we don't get into multivariate analyses in this course. That is beyond the scope of this course. However, I do want you to understand that because there are 3 variables here, this would call for a multivariate analysis. And there is a whole group of inferential statistical tests that we could rely on in order to test this multivariate relationship. So in summary, in this video, we have discussed levels of measurement, which include nominal, ordinal, interval, and ratio. And we have also discussed the difference between descriptive and inferential statistics. Now is the point where I will invite you to check for your understanding of these concepts. You can do this by simply completing this form and then clicking submit at the very bottom, or you can copy and paste this link into your browser. Or finally, you also have the option of scanning this QR code using your cell phone in order to complete this survey. I hope that this has been helpful, and I look forward to seeing you in the next class.